Thank you for giving me a little bit of attention. That's nice. Thank you. First of all, welcome to SID 2022. It's a pleasure to once again be the host of this event. It's really good to see that there are so many people. We actually had to close the registration some days ago because we got many interesting people wanted to attend, which of course is fantastic. So that's a good thing. That shows that this gathering, this day to show technology and let people meet and discuss solutions is welcome by the others. So that's really nice. This event, of course, is totally dependent on that we have clients and also partners with us do this. So on the side, we have different partners now, some that we work with for a long time, and also some new partners. And they have stands and presentations of the products out in the area. So it's important for everyone to go out and see. Practical stuff, toilets. There's a toilet just around the corner here. There's also toilets up on floor if you go through the stairs at the end. And there's also, if you go out again and all to the top, there's toilets there as well. Emergency exits, we got several. We got the door on this side, door on that side. There's also ways out on that side. There are no planned emergency testing or sirens testing. If you see me running to one of the doors, you should just follow me, so then at least you come out quickly. So then there's probably something serious going on. And of course, for us then to host this on behalf of NOSP is a privilege. We also hope we can do this for next year as well. I hope to get agreement. Okay, that's good. Yes. Okay, now we can give my next slide. I just wanted to give you a little short status of where we are with RTS these days. We have quite a lot of things happening. One thing, the number 100 for us was the thing we need to focus on this SID, because that was actually the maximum people that we could accommodate there from client side. We are also more than 30 people ourselves. So the number 100 has been like a discussion for many weeks. How many people are we actually able to get into the venue we have and still have it safe and people are feeling comfortable and okay. So 100 was an important number. And we reached that, and that's why we then had to close the invite. So probably next year we need to see how we can accommodate an even bigger crowd for next year. But it's so good and so nice to see the interest of actually this event. So that's really, really good. Next thing here, there's a number 2002, 2022. Hopefully not too much calculations need to be done, but that's just 20 years. RTS is actually 20 years this year, founded in 2002, and today we are 20 years. So that's really good. Any applause? Everything? And if you see on the side, the 2002 is the green. That was the establishment of RTS. 2022, that number, the purple thing there, that has to do with this year, and it's also the color that you will see from the Gen 6 MUX thing, so that's the color of the Gen 6, so that is obviously the color you need to follow in the future to ensure that you get the right products. Also in 2022, this is the year that RTS now opens up an office outside of Norway. We have the main office here in Åkrehamn, we have one small office in Stavanger, and now we are actually these days going into the office in Bridgerton area just north of Aberdeen. And for that office, we got David Curry. He's going to be our managing director for that office. David Curry should be known to several people in here and also in the business that we're in. Where is David? There he is. That's the man. That's the man. Any needs on the other side of the pond, that's the guy to talk to. So we are increasing things, and we have the office now to be able to support our clients, both existing and new ones. We also, to increase engineering capacity, we've opened up an office in Spain. So that's going to be engineering office. So the part here, this is the year that when you're asking where RTS is located, you need to zoom out from Google Maps to see where we are. So that's an important thing to know. So in 2022, there's a lot of things happening within RTS, and this is one. Last one, we have the, many people heard about the Gen 6 maps should come to the market. We talked about it for a while, people have been looking at the spec. It's now here, it's out there in the showroom. And of course, Gen 6 is very much known, but Gen 5 is very much known. Gen 6 is going to be an even better product. We also are going to do something with the Nemo, and we have an advanced Nemo, I would say, and that's the Nautilus. So though the things are presented out there, but we don't want any pictures actually taken in details. So you can look at it, see how it can work, but no pictures, please. Detailed pictures, you can make pictures, but no details. So that's me. One practical thing, there is going to be a photographer coming in here during the day to take some pictures of people that we will use for this event and also to be used on social media. So if there are people that don't want to be taken picture of or is restricted to that one, please tell us and we will avoid it. But the other ones, just for you to know, there will be a photographer walking around. That's me, and then I'll hand over to Stuart.
Thank you.
Sorry, one more time, I forgot something. Important thing. Steve, our new girl in marketing, she's going to be very angry with you if I quit. There are some small glasses on the table. That is actually truffle seaweed picked here in Åkrehamn, picked by RTS people, and it's dried. And that seaweed is actually very popular internationally as an additive for food and for gourmet restaurants around the world. And it's very expensive, so that's why you don't get a big bottle, you get a small bottle. But that's the thing. And there's also some writing on that to tell a little bit about the story. So that's one thing. Now I think we move on, and I have more details after all presentations.
Thank you, Tora. Very good to see so many people here. Thank you very much for all coming. Thank you very much to Tora and again for inviting us and putting up in such a show of food as good as ever, and just the fact that we can actually come to such a place like this and enjoy each other's company. And hopefully we put together a good set of presentations for you. There's lots of else happening, as is mentioned on the site. So just mingle and have a good time for the next 3-4 hours. I think things are going to be great, progressing in the evening. As ever, I think Freddie's going to be getting on the drums and dazzling us with his skills there as well. So from a NOSP perspective, again, great. We've really enjoyed the last few years trying to put things together. We couldn't do it without our sponsors. All of them, including the very last one that came in last week, Ocean Infinity. We are now up to 32, and that really gives us a huge boost for what we are going to be doing, hopefully over the years to come. We're 5 people in the team at the moment. I should point out that 4 of them are here. Derek, unfortunately, isn't. So Ricardo is my wingman. And we've got Odd as well, who plays a fantastic part, and John Vinn as well, who's just a stalwart of NOSP and will be here forever. So we are looking, though, it has to be said, that we are looking for an additional person to join the board and give us some bright ideas for the future. we noticed that it's incredibly white, this audience, and very few women as well. So we would like to try to get a little bit of diversity into the board. So if there's anyone who knows anyone else who's female and black, then give us a call. You know, we would really like to do things. We all would like to take NOSP a little bit up a level over the coming years, and I think I can go a little bit into that over the next couple of slides. So I've just mentioned a little bit about speaking opportunities. The 5 presentations that we have, I'll run through them later. They came together at the last minute for us this year. We wanted to get it done before summer. It didn't happen that way. As it happens, though, I think they are 5 really good and interesting topics and subjects by people who've been in the business a while. But I really do ask if there's anyone who would like to say anything about the business. We're booming at the moment. There's so much to say and so much is changing that I would like to hear from you and see if we can put you on the schedule. We like to have themes for the evenings. That's the kind of plan, and we've got some great stuff happening next year in Bergen. But if anyone's got anything, just give us a shout. It's really, if you've been on a motorcycle for 3 months and you mention the word survey, just that's legible. That's good. That's good enough for me. So just get in contact with any of the board or myself and show some interest to speak. So a little bit about what's planned now for the rest of the year. Crikey, it's incredible that we're almost in September. We've got a joint event with the Norwegian Petroleum Society planned for October in Bergen. I suspect that's going to be a really good event. We're splitting the presentations. Already confirmed our reach and Ava, so looking for another couple, but actually I'm not too concerned about that. So mostly the presentations, if anyone's interested, will be for next year. Of course, in November 17th, put it in your diary. I think we were 70 people last year. I would love it to get up to 90. I want to pack out the Bergen Moi restaurant down in Stavanger again. So we've booked it, everything's set. So we're planning not so many presentations that evening. It's going to be a slightly different event, much like last year. Move away from the presentations and do something a little bit interesting. So next year, 2023, of course, we are looking for presentations, as I mentioned. In probably April time, we're going to have an interactive evening planned down at Argus Remote Systems, planning to give everybody who turns up an opportunity to play with some electric ROVs. So that's one of the good things that we're looking forward to next year. I'm also, on behalf of the sponsors, talking to Haugesund of Vestlandet, one of the schools up in Bergen, about improving and maybe even getting a hydrographic survey on the syllabus so that we can actually bring in the next generation. So that's a part of the NOSP initiative. I will hopefully be able to present something about that next year at one of the NOSP evenings. So lots of interesting stuff happening from a NOSP perspective, and anyone's got any bright ideas for us, we're all ears. So please come forward. So a little bit about tonight. I have the pleasure of presenting myself later. That's going to be odd. But first up, in a moment, Michael King from Ocean Infinity. Ocean Infinity need no introduction anymore. They exist and we're all playing catch up. So I think it would be nice to get a flavour of where they're at the moment and see what we have to do to play catch up with those guys. Then I will be talking a little bit about the Hywind Tampen project that we've been involved in this year. I actually had my colleague talking about it last year. That's now going ahead or halfway through, so that's quite an interesting subject to talk about. Stuart Bitter will be talking about some cameras from behalf of Fugro, and Sondrine from RTS, which I presume is, I presume that must be coincidence that it's so closely affiliated to RTS. But, and then I'm really looking forward to this one because I got so invested in the first one, but Rasmus Bong from NOSP will be presenting some of the results that we had from the dinner last year, which I think some of you were there for, some weren't, but it was a really good evening. I think it got slowly, went downhill, more alcohol was consumed, but some of the results I think will be very interesting to hear in such a large audience. And the topic is very pertinent, of course, to everyone here concerned. What is the future for us in the North Sea, and maybe slightly further afield. So thank you very much again for attending. If there's any questions for me, I'll be around until late. But on that note, I think I will pass over to Mr. King. And well, there we go. Always a pleasure to listen to this chap speak. So I think, yeah, we'll take let's sort the microphones out and you can talk into that one. Or you can use that.
No, I'll just move that a bit closer.
Yeah.
Yeah, we're getting there. Yeah, we got the presentation screen somewhere though. Because where's the kind of advanced next screen isn't up, is it? Yeah, okay. No, I'll use that one just. Yeah, no, that's okay. All right, I think we're up and running. Hi, good afternoon, everyone. Can everyone hear me? Hope so. Great. So yeah, it's great to be back in a busy room here at RTS. I last spoke here 3 years ago in 2019, when I'd been at Ocean Infinity for all of about 10 days. Hopefully I'll be able to share a few more details today than I was back then, because I was learning it as I went along back then. So yeah, I'm much more involved now, as you might imagine. But firstly, my name's Michael, or Mike. Everyone calls me Mike. I've got a technical background as a geophysicist. I started my career working offshore around the world in seismic exploration, and then moved back to Europe to work on hydrographic and geophysical surveys in the offshore renewable market. Since about 2016, I've been involved in commercial management and business development, focusing mostly on uncrewed systems, new technologies, remote and robotic solutions as well. I'm currently a senior member of the commercial team at Ocean Infinity, primarily focusing on our new Armada fleet, which I'll talk to you a little bit about today. I sit on various industry steering groups, such as the Geological Society of London's Marine Studies Group, and I'm chairman of an IMCA committee on autonomous systems as well. Today I'm going to talk a little bit about the background of Ocean Infinity, where we've come from, where we're going, but also touch on a few of the recent technological advancements we've made, and of course talk a little bit about the vessels that have started launching as well. Why hasn't that worked?
There we go, okay. But firstly, a brief introduction to why we do what we do. I mean, it says there, Ocean Infinity's purpose is to use innovative technology to transform operations at sea to enable people and the planet to thrive. It's a simple enough statement, but achieving this and trying to achieve this in everything that we do really focuses everybody who works for Ocean Infinity on the ultimate goal of the business. We want to redefine an industry. We want to push boundaries through innovation for our clients in the marine sector, but also outside of the marine sector as well. We want to deliver efficient operations. We want to use the highest quality technology with the highest quality outcomes. We want to put people and safety first. And we want to lead the digital age of uncrewed and robotic technology to allow companies, stakeholders, and ultimately countries and governments to enjoy the benefits that we can bring to them. We have environmental responsibility and sustainability at our very core. Everything that we do, everything that we try to do in the industry is to try and make it more sustainable. And I think we all agree that that's necessary, particularly in the industry that we work in. Because when we thrive and the ocean thrives, then people and the planet thrive too. As some of you know, we started a a few years ago with the concept that really struggling with this here. We started with the concept that existing technology could be better applied to the marine environment by scaling the use of multiple robotic systems. We started with some deep water AUVs, as you know, and the idea that seabed mapping, inspection, and data acquisition could be improved by deploying more than one AUV at once. And that's kind of how Ocean Infinity was born. We carried out a number of high-profile projects, as you'll be aware, and we continue to do so. We continue to do so day in, day out around the world for governments and our clients as well. However, in 2019, we kind of took the decision that if you took that same ethos of using new technology at scale, you could really change the way that the whole industry works. And the Armada fleet was born. Now, Armada, we hope, is going to be the future of offshore operations. 22 custom-designed robotic ships ranging from 21 meters to 85 meters in length will have hybrid power and propulsion systems utilizing green marine fuels of the future. They'll have the ability to remotely deploy a series of payloads, both hydrographic and geophysical, but also ROV and AUV payloads to allow us to use our vehicles to perform services in up to 6,000 meters of water depth. We're also working on shallow and deep geotechnical payloads as well to really try and replace conventional systems and allow everybody to take advantage of the robotic technology that we're bringing to market. Since then, the group has grown pretty significantly, as you'll be aware. We went on a bit of an acquisition spree in 2021. And each of those companies that we brought into the group brings something to the table. You know, they're all world-leading companies in their own right, from data analytics and presentation, software, hardware, remote handling systems. All of that's bringing together to genuinely try and build a group that can revolutionize the industry. Now, alongside that, our global footprint has grown. We've got our first remote control center in the UK, but we've also just commissioned our first operations center in the US. A senior team actually flew out to Asia this week to scout locations for a remote control center in Asia Pacific. And we're moving our chief operational officer. She's going to move to Singapore for 3 years to set up our Asian business as well. So we genuinely have global ambitions. We're all really excited for what the future holds for Ocean Infinity, both this year and beyond. So today I'm going to talk to you a little bit about how we're going to achieve this, some of the findings from the initial trials of our remote systems and vessels. But first I want to show you a little video about what we're already doing in the industry to change the way it works. Why does that stop? I'm going to skip the rest of that because it's really jumpy. It shouldn't be like that. If anybody wants to see that video, come and find me afterwards and I'll show you. It's really cool. But it's obviously not working very well with the IT. So we'll move on. So we use some of the best technology we believe in our industry. And there are 4 main elements to help us achieve what we do. So firstly, our marine robotic technology helps us primarily to reduce the number of people at sea. We remove them from a dangerous environment and we open up a great career to people who are unable to go offshore for any reason. We're developing future marine fuels, as I mentioned, for the Armada fleet, which is key in our goal of becoming carbon neutral across scopes 1, 2, and crucially scope 3 by 2040. This is a pretty ambitious target, but we're serious about it and we've been accepted as signatories to the Global Climate Pledge, which independently verifies our commitment to this. Our smart digital software tools allow us to provide answers for those that need them in the most efficient way possible. Utilizing machine learning and automating as much of our data processing and analytics as possible, frees up the experts that we have to really add value and ensure quality deliverables. Running everything through the Ocean Infinity cloud gives our clients even more access to the results that they're paying for, but also allows us to embrace truly remote working on a global scale. This helps us improve staff retention and the work-life balance. Thirdly, we design and produce automated load handling equipment for both our vessels, but also for third-party facilities as well. Running the command and control through our Ocean Infinity network, that I'll talk about in a bit, enables us to leverage those advanced systems that we've got and really bring together a lot of different services into a single contract. And finally, our remote control centres bring all of this together and provide a focal point for our global operations. There's a huge focus on the human factors of everything we do at our RCCs, and being able to build these from the ground up has really given us the chance not only to future-proof them for the next 20 years, but also design and implement a revolutionary network infrastructure to allow us to realise the full benefits of remote operations and robotic campaigns. Remote control centres, remote operation centres, mission controls, whatever each of us decides to call our own facility, they're not new anymore. Remote operations are alive and kicking and used to great effect all over the world. But when considering the infrastructure required to support remote operations on the scale that we're setting out to do, you have to think a little bit differently. ROV piloting has been done from shoreside control centres for years now. USV control is taking place over satellite communications as we speak, and remote access to data handling, processing, and analytics is commonplace. However, bringing all this together into a single enterprise IT infrastructure and needing it all to run simultaneously and synergistically hasn't yet been done. So when we set out to design and build the first of our global remote control centres in the UK, it was important to have ultimate flexibility. We didn't want to have separate kind of dedicated vessel pilot stations, ROV pilot stations, data processing stations. We wanted everything to be multi-role and modular. All the terminals and all the stations needed to be adaptable for different tasks. It would have been impractical to base all of this around a physical terminal and cables plugged into a physical computer. Everything requires different hardware and different software. Therefore, we've created a completely virtual environment across our Southampton facility with total redundancy in communications and power. So, for example, in Southampton, we have 20 operator stations initially, but there are over 350 virtual machines running in the background. This enables each of the operators at each of the stations to select and choose the information that they have. Now, we've also gone even further than that. So rather than connecting everything with physical cables, which introduces latency and limitations to what can and can't be shared across the network, everything runs on a multicast real-time transfer protocol. This means that any internet-connected device in the world can log into our cloud and can view data streams in real time without degrading network speed. It also enables us to build a prioritization network so that information, particularly from a safety of navigation perspective for the vessels, auto-triggers and auto-displays to allow vessel operators access to the information that they legally have to have at every point in the project. We still rely really heavily on human-in-the-loop operations, as I'll touch on a little bit later. But the same type of system constantly monitors our bandwidth at a network level to track, to tag, and keep track of information and packets of data. This allows the operator of either a vessel or a vehicle or a particular type of payload to make safe and informed decisions about what happens to that vehicle or vessel. It allows reallocation of bandwidth where required, and it feeds through our dynamic payload control software to make sure that the projects that we carry out are both safe but also efficient. So complex as all of this is, it isn't the only thing needing consideration. Our entire facility in Woolston in Southampton on the south coast of the UK has been designed with a huge emphasis on human factors, especially the RCC itself. The ergonomics of operator stations, the lighting, the temperature, the humidity, the textures, the colours, everything has been carefully designed and chosen with a series of pretty advanced consultants to promote the most healthy, safe and effective working environment for our staff. Ultimately, we assume that the shifts worked within our RCC will be similar to the shifts worked offshore on a conventional vessel. So the chances are that our staff are going to spend long periods of time in this room, in this building, in these chairs, and we need them to be, as safe and as comfortable and as, anti-fatigue as possible. Even things like the elevated mezzanine floor in the middle, the glass walls, central supervisor and monitoring stations, the whole environment was modelled in multiple different ways to ensure both operational efficiency, but also promoting the highest level of physical and mental well-being for the staff. Even in a world relying on advanced technology, our team of experts are responsible for safe and efficient operations at every stage. And without them, we wouldn't be able to operate. Our vessels will be automated rather than autonomous to begin with, and human-in-the-loop operations are absolutely crucial. Now, as we move towards the trial phase of our remote setup over the last 6 or 7 months, it was clear that a few major hurdles sat in front of us. Of course, building the largest robots in the world brings certain challenges, not only in design, but also in the regulation and safe operation of these ships. I could stand here and talk literally all day about marine regulations for remote vessels, but I'm not going to. Feel free to be pleased about that. Secondly, trying to build one of the most technologically advanced and complex shipbuilding projects the world has ever seen is pretty daunting. Throw into that an unprecedented global pandemic, a war in Eastern Europe, and you begin to understand why the initial Armada ships have been a little bit delayed. Putting all that aside, I wanted to focus today on information transfer and how we do some of our data handling. We're revolutionising both ship-to-shore data transfer, but also crucially shore-to-ship as well, which is sometimes forgotten. And hopefully I'll be able to talk you through that a little bit. So communications and data transfer is literally at the heart of everything that we do. From vessel and payload control to data analytics, collection, appraisal, reporting, everything relies on maximising the amount of information that we can transfer over the internet. It's all in a low bandwidth, high latency environment, and that obviously brings its own challenges as well. Now, despite all the technology and infrastructure that we're investing in, we are a data business. Yes, we're building ships, we're purchasing equipment, we're launching different vehicles and vessels, but we are a data business. We provide answers for people. Yes, they're against scopes of work, but ultimately what our clients are paying for is the answers at the end of the day. Yes, they want it acquired safely and effectively and cost effectively, but we're a data business. We provide answers for people. As a result, we have a real need for not only the most accurate data set, but sometimes these are required in very short timeframes. I know a lot of you will be aware that weeks is kind of standard, days is not uncommon, and even sometimes clients want answers within hours of the data being acquired. Throughout all of this, there is a huge emphasis on data quality, usefulness, and repeatability, and this certainly doesn't diminish with the use of uncrewed or robotic ships. Now, to begin thinking about data transfer and how we conduct it differently to other people, we have to start thinking about the way in which it's been done for decades on a conventional vessel. So traditionally, you have a ship offshore somewhere in the world, filled with 50, 60, 70, maybe even 80 people, depending on the work scope. The offshore crew deals with payload control in real time, data acquisition, real-time assessment of quality, coverage, etc. This provides that hours or days time frame that the client sometimes needs. However, when that data comes ashore, a lot of it is reprocessed before actual final delivery to the client, either to improve quality or to provide different deliverables that are only possible from a shoreside operations center. But sometimes just because the team offshore haven't done a very good job. I should know I've reprocessed enough data from offshore guys to know that sometimes they just can't be asked. This takes time, it's costly, it doesn't look good in front of the client, and ultimately it's not the best way to do business. Our robotic approach allows us to do things a little bit differently. With no one offshore and bringing back that data to the remote operations center in real time completely eliminates that offshore-onshore disconnect. We reduce the impact, and all the appraisal and the analytics of the data takes place in the ROC, meaning that the final data deliverables can actually be given to the client much faster and generally of a higher quality. Of course, a lot of this relies on some of the methodologies that I've talked about already, but building a network infrastructure that allows this to be realized is what really is key to the whole business. As I mentioned at the start, we've had to find a way to continue our development in the absence of the first Armada ships. We're lucky enough to be based on the water in Southampton for ease of access to testing, but also we've built ourselves an analogous barge setup at the National Oceanography Centre just up the river. This is helping us integrate and test all of the sensors we have for the Armada ships. Underneath our barge setup, there is a subsea gondola fitted with all our hydrographic and geophysical equipment. There's an SVP winch and set up over the side, and of course our ROV Lars sat above the moon pool. Over the last 9 months, we've been working towards automated and uncrewed ROV operations beyond line of sight. We've now successfully completed over-the-horizon launch, missions and recovery, all monitored from the RCC. As I pointed out earlier, remote ROV piloting is nothing new, but to my knowledge, even over-the-horizon piloting requires physical real-time deployment and recovery from a crew offshore. Traditionally, when multiple platforms come together, like a vessel, subsea vehicle and payload, the only thing bringing those three things together is the human that's involved, the ROV pilot or tech or vessel master. It relies on a crewed ship with manual deployment and recovery. Our solution is to build an integrated remote control setup through our dynamic payload controller, which we call our DPC. This provides cross-platform synchronization and automated control for things like launch and recovery. It deals with the interlocks between the Lars and the ROV, the payload equipment, the vessel and vehicle cameras all feed into it as well. All control loops reside on the vessel itself. The DPC is being monitored by the control center, but at every stage, the operator has an approval process. So every time that it needs, or it works out that it needs to do something, it asks the human that's constantly in the loop whether or not it's safe to proceed. So it's automated, but human in the loop at all times. The other crucial difference to existing over-the-horizon ROV control is the way that we actually fly our vehicles from the control center. As I mentioned, we don't have traditional ROV pilot chairs with joysticks and buttons and things. Now, this brings its own challenges, but actually it enables us to fly our ROVs differently, which is proving very successful. We've developed a control system that relies on waypoint and mission-based automated control. In high latency, low bandwidth environments, you cannot simply fly a subsea vehicle in the same way that you would traditionally. There is enough communication to use a joystick, but ultimately we can't just say to an ROV, thrust forward. That doesn't work in a high latency environment because that latency then allows you, it doesn't allow you to pilot it in the traditional way. We have to build commands into our ROVs such as fly forward 10 meters or turn 4 degrees to port or something like that. You can't just have a joystick and say thrust forward until I tell you to stop, because the latency will introduce too much error. Additionally, because of things like the tether management, ROV thrusters, payload control and camera systems are all feeding into the DPC, we can simply dictate a mission path or a waypoint control system, which the ROV and the DPC will actually calculate themselves how to fly an ROV mission. If this isn't desired, we can use a semi-automated nudge technique to fly an ROV mission, but ultimately the automated mission path is what we're heading towards. As with the launch and recovery, the operator has control over the frequency of updates that they have to give the subsea vehicle. This has worked pretty well so far, and we're looking forward to trying it out offshore early next year when we take delivery of the first vessels back in Europe. I have another video, but I'm going to skip that as well, I'm afraid, because I don't think the IT is going to support it. So what have we learned from the recent trials as we push towards Armada operations when the vessels arrive? Well, firstly, we've successfully tested and trialed our payload command and control, and with that, the real-time monitoring of data quality and file health over low bandwidth. We've worked on our quality assurance processes, and we've worked out what would ordinarily take place with the offshore team, replicating that experience from the comfort and advanced infrastructure of our remote control center. These are some key steps between now and fully fledged uncrewed operations, and as we transition to a more robotic future, these elements will form the basis of our data journey with our clients and with our uncrewed ships. We're currently working on more data standardization and governance as it moves through our handling process. We're using more automated analytics and appraisal, and we need that standardization to assure that the same high quality products are being produced for our experts repeatedly and safely. This also allows us to move ahead with a lot of our machine learning that I'll touch on another time. But as with marine regulations, I could talk to you for a long time about that. but sadly I don't have the time. If you want to know more, please come and find me at the break. But everything that we're doing is really trying to fit into an automated future, not only from an acquisition perspective, but also from an analytics perspective as well. And in the future, well, we have some big ambitions, as you might think. We want to create kind of universal data journeys. We want to create universal data packages, not only for ourselves, but also for our clients, so that things like governance and strategy can be centralized across different clients, different projects, different market sectors. The amount of information available from a single data set is going to increase as we use different sensors, better sensors, more sensors. The amount of data that you can acquire from a single vessel in a single project is going to increase exponentially. And full digital twinning of entire subsea environments is not too far away. However, this relies on not only more data as a snapshot, so you get real-time updates, but also getting more information out of each of those data sets. I wanted to finish by putting this slide up again, because ultimately, as I said, this is what it all comes down to. All of our technology, all of our innovation, all of our considerable investment allows us to complete some fascinating projects in fascinating parts of the world. But it's also trying to redefine what we're doing as an industry. And I believe that we all have a part in that. We all have that responsibility to the ocean, to the planet, to try and do what we do in the most sustainable way possible. And that's why we do it. So thank you very much for listening. I think I've got some time for some questions, so I'll be happy to take them now.
Once again, very interesting, Michael. Thank you very much for that. I've got a couple of questions, but I'm sure that people do have some questions I can run around, and if anyone's got one, just put their hand up, otherwise I'll put it up over there. I would actually quite like to ask just a quick question. This is very highbrow, I feel. Are you ultimately trying to push your clients to like a psychological change in attitude to how they do things? Or because it does sometimes feel almost over the horizon type of thinking, but clients aren't potentially, I'm not offending any clients here, not thinking that way yet. Is that, or are you ultimately just pushing it for the sake of pushing it, when you do feel that you can actually achieve something in it?
I think it's both. I'd love to be able to influence my clients that easily. No, I think it's both. I mean, there is a certain amount of building and they will come, but I think it's also a case of making clients and other stakeholders and the rest of the industry aware of what is possible, i.e., making them aware that truly carbon neutral operations are no longer a myth. They are reality. And therefore, why not put into scopes of work or technical specifications the need to be carbon neutral? Why not put in requirements to do things in the safest and greenest and cleanest way possible? So I think it's 6 of one and half a dozen of the other. We'd love to influence them, but we're going to do this regardless.
But this investment is staggering, I would imagine. So that the return on investment is going to be something that you're obviously looking to, but would be somewhat pricing out clients at the initial stages, or do you think that they are ready to stomach that?
I think, again, it's some of each. Some clients definitely are and have told us as much. Some clients definitely aren't and have told us as much. But again, it's about doing it for the right reasons.
Yeah.
Yes, ultimately we're a business. We have a P&L that we want to hit, but we're doing it for more than that. We're doing it because we want to reshape the way an industry works. Sometimes that's going to mean that it's expensive. As you say, the investment is pretty significant, and none of this technology comes cheap. But at the same time, by doing it at scale, we're able to see economies of that scale and therefore offer competitive solutions, even with some of the more expensive technology. So yeah, ultimately, we'd love to be able to charge more for our services. I think we all would in this room, but it's finding out when that's appropriate and when it isn't.
Okay, one question here.
Yeah, thanks for the presentation. It was really great. You talked about a lot of people have been doing remote operations, I assume, of world-class ROVs for a long period of time. I wondered if you could elaborate on who those companies are that are doing a lot of this. And then just getting back to the presentation, the value that Ocean Infinity is adding, so you got your USVs and your automated handling systems. Can you talk a little bit more about, there's value there, but the differentiating between what you're doing compared to these companies that are doing a lot of remote operations that you've said that has been going on for a while?
Yeah, I mean, as far as companies that are doing it, I mean, the chap on your right does it a fair amount, I think. But yeah, I mean, the major players in the industry, Subsea 7, Fugro, Saipem, Technique, they're all using remote technology in their ROVs. I'm pretty sure Oceaneering is doing it at some point as well. So there are lots of players who are doing elements of what we do. Ultimately, what we're doing is nothing particularly groundbreaking. We're applying the same type of remote technology. We're just applying it everywhere, or we're trying to apply it everywhere, and making every element of it as automated and remote as possible. And that brings its own complexity. But we're using industry standard vehicles, industry standard sensors. Yeah, we're building our own boats, but everything on those boats is largely available off the shelf. It's some of that network infrastructure that kind of makes it a little bit different. So yeah, I hope that answers your question.
Thanks very much.
Yes, introduce yourself as well.
Yes, hello, my name is Björk. I work for RTS Subsea. I'm just a bit curious on the competence of the RC operators. Can you elaborate on that, please?
Yeah, so we've made the commitment that in order to remotely drive one of our vessels from the RCC, you will be qualified to drive it as if you were on board the ship. So we'll be using qualified mariners to do so, particularly from vessel control perspective. Likewise with ROV control, you will have similar qualifications as if you were doing it conventionally. That's a great question, because there's a huge amount of debate within the industry at the moment, particularly at a regulatory level, about what kind of tickets and qualifications mariners of the future will need. You know, do they need to be old captains who spent 10 years at sea to get their officer of the watch or master unlimited? Or actually is some 19-year-old kid who's a whiz on a PlayStation a better bet? I'm not suggesting they are, but those kind of conversations are ongoing in particularly government circles at the moment, from the likes of the Coast Guard and different flag states, because it's a different skill set. You know, yes, there's never going to be a true replacement for experience, but ultimately the experience that people need to do this remotely is very different than the experience you need to do it physically. So yeah, first and foremost, we will be using qualified mariners because we see that as the easiest way to achieve regulatory compliance with the regulations as we see them today. But I think the regulations will change pretty rapidly as this becomes a reality over the next few years.
Hi, Benoit for C Robotics. Could you just indicate the type of ROV you're running from Southampton? I mean, work class hydraulic with tether, or?
So we're using Saab Leopard electric ROVs at the moment, and we've also got a fleet of the new Saab E-Rods on order. So from the Armada fleet perspective, we're going electric. Fewer people offshore. We don't want as many hydraulic hoses to play with. We also run regular hydraulic systems from our conventional fleet at the moment, but for the Armada fleet, they'll all be electric.
And do you implement any robotics smart motion control within the ROV smart pod, or I mean, have you modified, invested into the robotics within the ROV structure, or have you not touched it much and already?
No, we have.
Standard ROVs.
Yeah, we have. We work quite closely with Saab. I'm not an ROV guy personally, so I don't want to speak too much to it. I can put you in touch with people that are, if you want.
Yeah, but so because we are focusing on that part of the We don't have the money of it, but so we're doing the subsea mini-niche part, and I think it would be interesting to share some.
Yeah, no, we work pretty closely with Saab. I think Peter was meant to be here today, although I haven't seen him yet. Did he make it? He didn't make it. Okay, yeah. So someone from Saab was meant to be here, but yeah, we work pretty closely with them and take 90% of off the shelf and then kind of edit it a little bit to what we really needed to be able to do. But largely, it's fairly standard, just with a few alterations.
We'd love to talk. Thanks.
Sure.
One more? Phil.
Hi, Phil from ICT. I mean, what kind of redundancy have you got built into your systems which are requiring those? Big goes down offshore. How's that remotely?
Yeah, so I mean, as much as practical, really. I mean, firstly, the vessels themselves are completely redundant, so they've got two of everything. And so if something fails, we can't necessarily remain operational, but we can certainly safely recover equipment and return to port. As far as redundancy in payloads go, depends on the class of vessel. So, for example, our smallest Armada ship, the 21-meter vessel, we can't really fit much redundancy on there. It's a single ROV that we can mobilise. It's a single set of geophysical or hydrographic sensors. So ultimately, yeah, if there's a critical failure and we can't get around it in some way, then yeah, that would require coming to port or taking a person out to the vessel to fix it. On the larger ships, so from 36 meters and upwards, we'll be taking 2 ROVs, for example, not for simultaneous deployment, although I guess we could, but it's more a case of if one ROV fails or one payload fails, we can recover that ROV, deploy the second ROV with a similar payload and carry on working. We have to build in as much redundancy as we can, because ultimately we don't want anybody offshore to be there to fix it. There are, of course, compromises that you have to make there in terms of ability to ride out problems. But what we are seeing is that by speaking to our equipment providers, we are pushing them to improve and increase mean time to failure rates. Because ultimately we believe that we're doing this, we know others are doing it in the industry, and we think that the world is going to move towards this. Therefore, the amount of time between the need for physical repair and maintenance, the longer that gets, the better for the remote industry in general. But yeah, so to answer your question, we have 2 of everything when we can afford the space on board, but ultimately, yeah, there will sometimes be compromises about the amount of repair you can conduct offshore. And what I didn't mention is all of our boats, including the 21-meter ships, are coded to carry people and personnel. So if we ever do need to put people on board for short periods of time to conduct maintenance without coming into port, or to go and effect a repair, then we can do that because the vessels are coded as such. It's not the way we want to operate, but we appreciate that sometimes it might be necessary.
Okay, I'm going to have to wrap it up here because I think we're going to move on to my presentation. As ever, very interesting to hear what Manageability are doing. I always remember seeing Michael, I think it was 3 or 4 years ago in Yale, and I saw that the person following him had a very hard act to follow. And unfortunately, I put myself second on the list here today, so I will be following Michael now. So we'll just probably have a couple of minutes while we get ourselves organised. Talk amongst yourselves, and I'll come back.
What happened with the video? I think the mic's the best. Yeah, that'd be good.
These microphones you have to speak directly into it. This one's okay though, right? No, yes, to me like
that proximity he had, I thought that was quite good though.
yeah, I was straight on the limit all the time.
Okay. All right.
A little bit closer.
A little bit closer.
Maybe behind the fence, try to move the box for the microphone behind the elevator.
Okay.
Microphone.
There we go. Yeah, why not? Just get that up and I'll be happy. There you go. Is it not? Okay. Is this how we use this? Okay, everyone. I hope that's not working. Right.
Okay, everyone, can I have your attention? Can you please gather yourselves again and sit down? And we'll start the second presentation. We'll have one more after myself, and then we'll have a quick break, maybe half an hour, get a chance to exchange business cards, as I've seen that's happening already. So that's the whole point of the day. So that's possible. As mentioned, I think Michael is always Michael and Ocean Infinity are a very difficult app to follow, but I will do my best to talk about a project that was on the agenda last year with my colleague Frederick von der Veer. He was the project manager. We've now obviously gone live with that project and had some good experiences. It's certainly not as technologically advanced as Michael's or anything Ocean Infinity do, but still a very interesting project within a field that is seeing an explosion, not just here in Norway, but of course further afield in the UK amongst others. So I'm going to talk to you the best I can about the High-Wind Tampen project and the technical solution that we put together for the surface positioning, tow-out positioning and hookup. There's two phases to this, but I'm only going to concentrate on the second, which was for tow-out. So I've got three parts to this, just a bit of a project overview. I see that this project is just all over LinkedIn, so people are more than aware of what it's all about, but I think I'll go into a little bit of the details of the project, just to give you create a picture for you, give you a bit of a status where the project is as of this month, because it's not complete yet, of course, it's still got a bit of a ways to go, that'll start next year. And then I will talk a little bit about, as mentioned, the technical solution that we put together to fit the criteria that was asked of the client. So this is the Honeycomb Mooring structure that is put together or conceived by CMAR on the right-hand side. You can see that there. The High-Wind Tampen project comprises 11 8-megawatt wind turbines in the Norwegian North Sea. 88 megawatts in total, and 140 kilometers off the coast of Bergen, Slurborg actually, because that's where all the turbines have been constructed together and set up for the tow-out. So I think it was April this year, the Skandi Skansen went out and put the 19 suction anchors in and the 33 chains. So that was about a month and a half work. Went very according to plan. Nothing particularly challenging about that operation. That's kind of from a DOF perspective. I should mention that I'm standing here now with my DOF Subsea hat on and not my NOSP hat on. But that was a very straightforward operation and created a foundation for what occurred later on in the year. So currently the largest floating offshore wind farm, it won't be that for long for sure. I know there's Trollvind discussed and various other floating wind farm projects being planned. I just popped over that, but this is an unusual project in the fact that it doesn't have like an export cable to shore. The export cables then go to two local platforms, and they will present about 35% of the annual electricity to those two platforms. So I've been involved in two large-scale projects over in the UK, Quinty Moor and Greater Gavard. They comprise of just transmitting electricity to shore via export cables. This is unusual in that it's all very local to the platforms in the North Sea. So an unusual way, I'm sure the Trollvind, I'm not too sure of the details of Trollvind, but others will be requiring export cables to shore. So 35% electricity may not sound a lot, but it's considerable, and the wind offshore, of course, in the North Sea will be almost constant, I would imagine. So the nature of this High-Wind Tampen is of the spar buoy design, floating. The depth from surface to bottom of the concrete base is about 90 meters, so it's fairly extensive. There are other designs I thought I'd mention. The kind of the most common, floating wise, spar submersible tension link platforms, obviously coming from the oil and gas industry themselves. So probably I'm not familiar with the other two, and only had experience with the spar buoy. But there are, the industry is evolving huge in gathering pace. That every day seeing things change. So no doubt we'll see lots of new designs in the forthcoming future. So where we're at the moment, status August 2022, 7 of all the anchors are in place, of course, in the Honeycomb design. There was a really good LinkedIn 3-minute video explaining the why and what benefits the Honeycomb design brings. That's extremely financially saves a lot of money by having it in those designs, and you can take away floating wind turbines from one location and take it to shore and replace it with another if you so desire. So there are a lot of benefits with that Honeycomb design. All 33 anchors are in place, funded by the Wisconsin, as I mentioned. So 7 of those turbines have gone in already, and next year in April the 15th, now is a tentative date for start-up of what would essentially be phase 2. We will be going out with Scandi Iceman, and most likely the other times that we use this year, which I'll go on to a little bit about shortly. I do believe that most of the equipment actually is, the only thing that really is holding back is a couple of items that otherwise it would have gone, all 11 would have gone out this year. So it's a shame that because the summer was quite a good one for installation as well, they were knocking them out of the ballpark at points, towing them out within 3 to 4 days and putting them in again, then coming back and collecting the next one. So 3 to 4, 5 were going in over a month period, and 7 went in over just under 2 months. So not a bad installation rate. So that's where the project is at the moment. So again, we'll start again next April. So a little bit about kind of one of the requirements. It's all very easy. You can just make me think this is a glamorized rig move. In some ways it is, but there are elements and a lot of considerations that need to be taken into account when towing out and installing some of these turbines. We consulted a lot with the captains on the tugs and on the installation vessels as well. We had certainly had some poor experiences a few years ago that we didn't want to replicate with Scandi Iceman, which is ironic because it's our vessel. But we listened, sat down with them, and we came up with a solution that really was probably more extensive than we would have liked, but ultimately everyone went away and we are happy and we got some good feedback on it. So what they were essentially looking for is the positioning updates during hookup and tow out, quite self-explanatory, that's what you would need. Heavy updates as well, that's very key. And what was also very important was the mooring line and pad eye. They really needed to know where those were in relation to the tugs, all 3 tugs, and the floating wind turbine itself. So there was also some of the interesting aspects that I'll come on to a little bit later on, some of the lessons learned that came out of it where we need to make improvements, especially not just ourselves, but also actually with some of our subcontractors and the client as well. So, on these, I don't know if anyone's actually been onto any of these turbines. I have been fortunate enough to spend a bit of time on there. There isn't oddly as it is, it's a floating wind turbine to use renewable energy, but there are diesel generators on there. We would have preferred to have used those, but it was almost impossible to get access to that. So we had to come up with some savvy ways, nothing again very groundbreaking, but still innovative from our perspective of how we would provide power to the battery packs on the floating wind turbines. They all needed to be portable as well, because the client, Equinor, didn't want to particularly pay for 11 sets, so we tried to make it as compact as we could, and that was and light as well, to be lifted on and off, not just by humans, but there are winches on there to assist as well. So there was a fair bit of thought had to go into it, a lot of dialogue with the client that wasn't always free-flowing. I think that's just natural in these busy days that we've got at the moment. But but the key role for anything on this project was the lead tug, obviously the Scandi Iceman, which was the position, heading of all the 3 tugs. They were very demanding actually of what they required from us. By the end of it, we got good feedback from them about and they were very happy. So I just thought I'd show you what it ultimately looked like. This is how it looked when it was being turned out. This is just a drawing, but I do have Ava
navy pack dump, screen dumps is what it looks like. But there's the lead tug, 2 tugs managing it, and a 4th tug was used and would shadow the tow out. And when you got out into location, this vessel, the lead vessel, would then transfer to become the installation vessel. And the 4th tug is visible here, shadowing would then become the positioning. So fairly, like as I say, it took about 3 to 4 days to install, but that was the key part of what this was all about. So this was the Scandi Iceman, one of, so yeah, these are the project essentials. This is what we had to do. This is all that we required from early in the year to get ourselves to the position where we were comfortable to be able to turn this offshore and accurately position it. Tolerances were not exactly high for this. As long as the anchors were in place, everything else seemed to just flow. So it was, once everything was set up, it was very much a babysitting exercise, but there were lots of teething issues at the start. So there's a one-off installation vessel and 3 installation tugs, the Norma Sigma, the Olivia Venus, and the BB Octopus. So all of those had the AIS tug kit and the V113 of the hemisphere, which I'll come on to in a little bit. And of course the 11 off floating wind turbines. We also established a monitoring station at Slurborg. That was critical. We were there from day one with a manager that had to have all this viewed. He had to have it on his screen on a very regular update. So it was imperative that he was almost like he is an ex-submariner, so a captain of a vessel. So he was critical in providing us with feedback about what the captains on the Iceman and what the other supporting vessels would require. So with all knowing what we were kind of looking for, this equipment essentially was replicated. What was on the vessels was replicated in the office in Slurborg. So we, knowing what we were ultimately trying or being told to perform on this project, we went away and looked at some options. I mean, regular tug packs do the job to a degree, but we assessed what was on the market. We wanted to be modern. We wanted to be malleable as well. As a word I'll use it for another time. We wanted to be able to change things quickly as well. That's quite critical because things do change offshore when you're not able to interact with the other companies that are on location. So we had to change things as we went. So this was ultimately came down to cost. This is not oil and gas, this is renewable. As I was continually told, I wanted to put 3 surveyors on the vessels. The answer was, it's renewables, there's no money. We've still got we've got a job to do. So we looked at the options and we came up with 2 options for positioning ultimately. Positioning the floating wind turbine. And that was the economy package, which was the hemisphere, so it's essentially a trying to think of a Kongsberg Sea Path with a SATEL telemetry kit, so a position on the Scandi Iceman. It was quite interesting in the fact that Equinor, or the client, I probably shouldn't mention Equinor, but the client was put on each floating wind turbine an AIS unit, which is a navigation unit, thinking that would be sufficient. That was not sufficient. It was never really going to be from our perspective. So we wanted something that was more durable, that would be higher update rates and just less chance of dropouts. AIS is good for tracking vessels mostly, but with tow-outs we considered that was going to be insufficient. So another example of where we probably need to interact and interface with clients and clients on a more earlier in the process. So this was the economy package. This is ultimately the, I shouldn't have mentioned to this, but the other one was the deluxe package, which is the fog gyro instead of GPS for heading and the radio Wi-Fi for transmission. This was definitely the Rolls-Royce solution, which we obviously looked at, but for various reasons weighed up pros and cons of each. We looked at the hemisphere and the fog gyro. Basically, those are the 2 options you've got. The heading was slightly off on the hemisphere, but considerably cheaper. And then I think we're certainly finding it anyway from a survey perspective, trying to get hold of equipment now is not easy. Much like the airline industry, everyone's woken up and everyone wants to do everything yesterday. So equipment is actually quite difficult to get hold of. Gyros had a long delivery time. The hemispheres, we already had quite a few of them in-house, and we needed to buy about 4 or 5 more. But ultimately, it came down to cost. This isn't the oil and gas industry. So we did look at other gyros. There are other gyros available on the market, not just the ones you saw on the screen just now. But we looked at the MEMS, but ultimately we thought we're going to go with the hemisphere because we had experience with it. It was cheaper, and it fitted all the parameters that we needed to do the job. So it's economy versus deluxe, and the winner was, of course, the hemisphere. As I mentioned, I don't think, like the oil and gas industry many years ago, it's very much necessity now within renewables. It's a different mindset that has to be taken. It's very much cost effective, and I think that also will come down to some of the procedures that we'll be following hopefully in a few years from the client. That will drive us forward. So I think many years ago it might have been the deluxe model, but within the renewables it was definitely the economy. So what did the system, the hemisphere, the floating wind turbine survey equipment installation comprise of? Basically a hemisphere, antenna, and a cable. So very straightforward on that front, not that difficult. A SATEL telemetry kit back to the installation vessel, and this was the challenge of all challenges. Really, was the power. We were told that we should use the Åkrehamn, but we were told that we would only have it for an hour a day. That would obviously be insufficient for transmitting regular updates to the installation vessels. So we ultimately chose to design our own power boxes. This is down in the top middle left corner here, which is a regular car battery. And we obviously did some testing, and the units exhibited no loss of heading, which is what we wanted, and the batteries lasted for 6 days, which was well within the time frame for the installation of each floating wind turbine. What was very interesting for us, though, from an installation perspective or mobilization onto the floating wind turbine is if you're going, and this is where the advantages and disadvantages of different spreads comes into play, is that you haven't got a great deal of room to install equipment on a floating wind turbine. So I've put this drawing here because it shows you that if you go back one, you can just about see, maybe you can't. On the right hand side, there would be just below the bottom of the transition piece is where the hemisphere would be installed, and it's subject to masking of GPS, and therefore that reduces the heading accuracy. So that's why the gyros would have been perfect, but they could have also been affected by the amount of metal on the structure itself. So we had to bear that in mind. You know, if you look, you're almost losing 90% of your visibility to satellites. For the hemisphere, transmission, of course, is no problem. So that's why I thought I would show that as full of considerations. And as anyone in surveying will know, that survey is bottom of the food chain, the very last people to be considered about to do anything. So we rocked up and we put our equipment where we wanted to, came back the next day and they moved it all. So that really didn't float our boat too well, or float our turbine. So it goes to show that we need to be flexible, of course, in the design of the equipment, and we need to be maintaining this regularly, because we just weren't too sure what people were going to be doing with our equipment. They didn't know what it was for. They thought they could just move it. So anyway, we had 2 surveyors, online surveyors, mostly technicians actually, because of the technical nature of this operation. On the installation vessel, the tugs are pretty au fait. They've been the tugs now, captains and first mates on these vessels have been doing these sort of operations for years, and they just opened their laptops and got going. So relatively little for them to do, but we had 2 surveyors on the installation as of Scania Estimate. The first one out started on the 2nd of June, if I remember correctly. Again, I've shown this map because it's actually quite interesting. Right up until the last minute, we were debating with our client whether we needed to do a full geophysical survey of the cable of the route out. It harks back to the old mentality or set of procedures from the oil and gas days, whereas things may be slightly different now for renewables. And the procedures that exist have not been, we feel, brought up to date. So we obviously had to quickly nip that in the bud because there was no way we were going to go and do a geophysical survey of the entire route just to ensure that the floating wind turbine didn't drag along the bottom. But fortunately, we didn't do that. But it's worth noting that some of the industry has to ultimately change a little bit. Not a lot, just small tweaks. It's all that needs to be done to maybe move and allow greater progress into the renewables markets. So, we started this on the 2nd of June, and there we go, wonderful picture in Smurville. This is taken the Iceman, and the 2 red boats, for what they were called, started the first tow. Everything went very well, no issues whatsoever, and there's the first one on location on the 10th of June. So that is really the crux of my presentation. It wasn't as technologically advanced as I mentioned as Ocean Infinities, but it's a necessary part of what we're all going to be doing going forward. It's a survey project, ultimately positioning, and it was a very interesting project to be involved in. And at the end of the day, also gave us the opportunity to take some fantastic pictures, both near shore. Some of our surveyors got very arty towards the end, and were sending me lots of lovely pictures. Yeah, and so I just wanted to ultimately kind of some lessons learned, which I've mentioned quite a lot actually, really, as I've been going, is that updated guidelines for renewables. This is the first big, large-scale offshore floating wind project in Norway. There's potential there to improve some of the procedures, some of the guidelines, and how we do that. Earlier consultation of the contractor in the project workflow to save cost, time, and resources. We struggled to get the information that we thought we needed to do the job and the professional outcome that we wanted ultimately to deliver to the client. So again, small tweaks, nothing major, just maybe some changes in some mentalities and attitudes. There are so many contractors involved in these projects, not unlike oil and gas, I'm sure, but greater interface management of contractors would save time and a lot of money and again resources. So it's just a learning curve. I've been involved in offshore wind for about 10 years now, and ultimately I haven't seen much change really from the Greater Gabon and Quincy Moore projects to what we're doing now. So it would be nice that maybe in the next few years things improve. They will, of course, ultimately. And the other one is that technical solutions, they all seem, this was a kind of a turnkey, bespoke solution, but it won't be the same for the next one. So we might have to go with a deluxe version, or we might have to go with something in between. We'll have to wait and see, but we look forward to working on 12 wind, and we look forward to finishing this project next year as well. So thank you very much. Hopefully that was informative.
Hello? Yeah. Thank you, Stuart. Interesting project.
Welcome.
Applying tried oil and gas techniques to renewables.
Yep.
Hoping for next year with an update on the year on. We have time for some questions. Can you to raise your hands?
No? That's always a bad sign.
You get off lightly.
Yeah. That's okay. We can move on to the next one.
Somebody must have a question.
You're flattering me.
Hi, Stuart. Thanks very much for the presentation. I'm actually interested in foundation installation and what type of accuracies you're talking about when placing these foundations for wind farm.
Well, we've been doing,
Suction fast.
Well, as a surveying department manager, that's probably a little bit above me. I'm kind of more on the operations side. I don't know the accuracy on the suction anchor, but we did perform DIMCONs on all the suction anchors before they went out, so I know that the tolerances were high for the installations. To the exact installation tolerances, though, I wouldn't be able to tell you. But the mere fact that we had RTS cubes actually on board, mounted on the anchors during installations, and we did DIMCONs, would give me the impression that it is to a high tolerance. Yes.
All right, thanks.
Yeah. All right. Oh, there's another.
Oh, yes, first, please.
My name is Thomas Stuart, working from a small company called Geograph. I just wondered, electric cables out there, are they put down prior to installation, or is that something which comes after?
It actually comes after. I think we're talking about 30 kilometers to the inter-array cables will go between the turbines, and then there's the two export cables that go directly from what I would normally see as a base station, but that's not part of this field. But the export cables go directly to the Gulfax and up. So yeah, the inter-array cables are installed afterwards, as I understand it, unless anyone wants to correct me otherwise. So, all right.
One last one from
Okay.
One last one from Ricardo.
From board to board.
Thank you, John. Well, Ricardo from NOSP. Just a quick one. You mentioned about the challenges in the end for the renewables. In your opinion, what would be, let's say, what would be the best to improve in terms of subsea methods for working towards the renewables?
I think it's just earlier dialogue with clients. I think not coming in, as I mentioned, surveys one of those things that no one really understands, just some black magic, so we give that a wide berth. But engaging with the subcontractors at an earlier stage, be that food growth, be that iSurvey, be that DOF, that would be my recommendation. I think not just for DOF or as a company executing these sort of projects, but that would be my recommendation to the industry. I think is a greater inclusion of the subcontractor at an earlier stage. Yeah.
Okay, thank you.
Thanks very much.
Okay, thank you.
Actually, I think it's interesting.
Hello. I don't mean to shout, but please be seated. Hopefully you've had a chance to refresh, eat some treats, get some food. We are definitely missing the entire table over there on the left there. Okay, I think we're going to start. Are we ready? Yeah. Okay.
All right. I can just go. All right. Perfect. All right. Hello, everybody. Thanks for having me at my first NOSP event. So quite excited to do a presentation. My name is Stuart Bitter. I'm based in the Netherlands. I work for Fugro. I've been with Fugro now for 4.5 years, almost 5 years. 2 years in my current role as a product owner for vision technology, focusing on product ownership, which is quite exciting. I love commercial management, business development, technical management, finding new opportunities. So it's a bit of a spider in the web kind of thing. I think Fugro needs limited introduction, but I would like to say a couple of words before we really dive into the topic of today, which is using machine vision cameras for offshore asset installation. So as a company, Fugro supports clients all along the project cycle. I think most of you know us as a geotechnical or geophysical data company. We are actually a geodata company, so we do a lot more. We actually also analyze the data, we advise on the data. And we do that over a couple of business lines. The topic of today is clearly offshore. It's what we call the marine asset integrity environment, and specifically positioning of assets. As I mentioned, topic of today, using machine vision cameras for subsea asset installation. What exactly does that mean? That's for installing heavy structures, you actually need quite heavy sensors. I think we all are used to the classical positioning jobs where we have either a wellhead to install, a subsea anchor to install, and we have to mobilize either USBL or acoustic signal beacons or gyro packages. Typical examples, I think you see here on the right. They mobilize on the assets, you dimensionally control them in, you test the signals, and you do your installation job as requested by the client. However, using these type of sensors, they carry a certain risk. And I've provided a bit of an overview of this risk. Most of these sensors are actually based on batteries. And no matter how well you plan for your job, these batteries carry an inherent risk of failure. They can be charged at the start of the job, but sometimes we work at very deep waters. They can be turned on before actually lowering the structure, of course, and the battery may run out of power, leaving you basically blind on the exact position or orientation of your asset. Acoustic signal loss can occur, so if no cables are attached to these signals, to these sensors, how do you get the right information all the way up to the top side or to the vessel? So something that is risky as well. There are some safety concerns around using these sensors. Most of the time they're heavy. Lifting operations are involved in installing these sensors. And in every lifting operation, you need careful planning, the right safety procedures in place, because in itself, a lifting operation is something that you want to do carefully and planned, but will bring a risk no matter how well you plan for it. And the last point is installing sensors, but especially also removing sensors from a structure can be quite a time-intensive job. You need an ROV to be in place, sometimes you need divers to be in place, but removing that sensor can be quite risky and time-consuming. Oh, a bit too fast for the computer. Perfect. This was the slide I meant to show. So what do we think is an alternative to this? How can you actually replace these physical sensors on the structure? And we believe we can do that with cameras, and not just regular cameras. It's not like a webcam. They're called machine vision cameras. And what we mean with machine vision is that we can actually tap into the data stream of this camera. We can use the actual footage as if it were a sensor. The camera is an actual sensor. On the left, you see the in-house designed cameras of Fugro. They're depth rated to 3,000 meters. And inside of this bottle, the housing, there is this machine vision camera. But there's much more to it. It's not only a machine vision camera. We actually build in a small computer, a GPU. And that GPU is able to run part of the algorithms that we require for positioning assets from that camera. It's something that we call sensor fusion. We're not just using the camera, but we're using sensors on the ROV as well. Because we're running part of that code or the vision algorithms inside of the camera, it's a camera that's easy to then integrate in any type of ROV. So basically, if you have an open Ethernet port, you can plug it in, the camera will interface to the web UI, and it's easy as that. This is all leading up to something that we call Quick Vision. It's a software package that Fugro developed and works with the camera, and I would actually like to introduce it by means of a video. More like moving pictures again. Is this watchable or should I just skip over it? Yeah. All right, I think that was a proper introduction, a bit choppy, but I hope that got the point across. So Quick Vision is Fugro's patented vision solution for subsea asset positioning. And to clarify a bit on the functionality, I would like to split up the software package into two software suites. One is Quick Vision Tracking, and from the video, Quick Vision Tracking is tracking the asset by means of putting a pattern on the structure and tracking the pattern. And because we know the relation between the pattern and the structure, actually tracking that structure in real time just through a camera. Quick Vision Augmented Reality, it's actually just a camera. And we can project augmented reality tools into the video stream by combining the data of the camera and the tools or the sensors that are on the ROV. We can actually make accurate measurements like inclination, heading, or elevation. So let's first zoom in a little bit on Quick Vision Tracking and what does Quick Vision Tracking do? Well, naturally, when you're doing a positioning job and you're asked to position a structure, you're interested into the position, the depth, altitude, and the heading, pitch, and roll of the structure. Instead of placing physical sensors on your asset, we can remove these sensors and get these readings directly from the pattern. So the only thing that you have to install on the structure is the pattern. So placing the pattern, in this case on the conductor, and dimensionally controlling that pattern on the conductor, we can simply just observe through the camera the exact pitch, roll, and orientation. We do that not just with a camera. we actually combine it with sensors that are typically available on that ROV. So that can be either a gyro, an INS, USBL if you're interested in the exact position of your asset. Combining that with the video stream and the readings that we get from the pattern, you get the accurate data from your asset. So this is an example of quick vision being used for a wellhead installation. You see actually two patterns light up. That's the algorithm detecting the pattern. It's telling us I've got a good track. It's telling in the interface as well how many of the dots, the black circles are detected. You actually only need 8. Most of the patterns we use have up to 28 of these black dots, so there's a built-in redundancy. And you can use as many as you want. It's a relatively cheap to produce thing. It's a sticker file. So place 8, 9 all around the structure, have them loaded in the software, and that's all you need to get all the accurate information on this asset positioning job. On the right, it's a typical surveyor interface. In this case, for this wellhead. They were using 2 ROVs to observe the structure from both sides, and you will get up-to-date real-time information presented in any overview. In this case, it shows for a 2D map. You can also choose a 3D map and have an actual graphical representation of your job in real time. The pattern tracking also brings another very convenient functionality, and especially in follow-up work, this is used a lot. So whenever a prior campaign installed a structure on the seafloor and a pattern is already available, you can use a principle called relative positioning to position the other asset on top. And this will remove the complete need for any USBL positioning, LBL positioning to be in place. So your ROV can basically only use the camera and a gyro to position this structure on top of the other one. And it saves you a lot of headache with USBL systems. It can remove that from your project, for example. And it's a good alternative for these type of scopes. Then zooming in a little bit on the Augmented Reality Toolkit. And I think the Augmented Reality Toolkit always presents itself on more random occasions in the project. So whenever we're already in the field and something pops up that needs to be measured, it's this toolkit that we call. I've got 3 videos, and yeah, it's a bit risky, but I'm gonna try to play them because they have an excellent demonstration of these tools. This video, if it's going to move, yeah, it's a demonstration of the Protractor Tool. So here we use just the video camera and the sensors on the ROV to project the tool into the video and take an inclination measurement of a wellhead. By flying around the structure and taking several snapshots, we can actually make multiple photos, multiple measurements, and combine that into a report that will quote for you an inclination and an inclination direction. And as I said, no patterns are needed, no other sensors are required. It's just video camera and your ROV that will facilitate for these type of measurements. Another one, which is really convenient in, for example, also conductor installations, is to project physical marker buoys. So when you have the coordinates where the buoys should be installed, you can actually make a separate installation campaign completely obsolete. Of course, you need positioning for your ROV, because that's what the camera is using for projecting that virtual marker buoy into the field of view. But here you can actually see the actual marker buoys overlaid with virtual marker buoys. You completely mitigate the risk of marker buoys detaching if you have an installation done quite in advance. So really a useful tool for positioning. And the last one, mostly used when inspecting structures, is an elevation line. I mean, you can calibrate it to whatever data you require. In this case, we're measuring against sea level. Just simply projecting the level line, flying up to the structure, you will find the elevation from seafloor. A bit more advanced in the Augmented Reality Toolkit is the bounding box or virtual structure. And this was actually quite an interesting job we did a while ago. This was for a client in Brazil, and this is a guided conductor installation. And the client was concerned about the azimuth, the heading of this particular structure. But obviously installing patterns on it and observing these patterns will make it very difficult to get a continuous track. Either you have to install them all along the conductor, or you will lose track at some point. So we introduced this bounding box, and you can see that white line on the guided conductor, and that was the reference for our surveyor to actually take a measurement. So by placing this virtual box over the guided conductor, we got all the relevant parameters like azimuth, pitch roll, and position. So quite a convenient tool, giving you the real-time information, and you didn't have to stop the job to get those measurements in. So why would you like to use machine vision cameras or quick vision instead of using the status quo type of technology? And first of all, it's risk mitigation. So not having to do lifting operations on board of your vessel, no work in the yard, but simply placing a light sticker pattern and dimensionally control it on your asset saves a lot of risk offshore. Not having the risk of batteries failing or sensors failing or having a faulty acoustic signal, of course, is also completely mitigated because a pattern will just be there on the structure. Installing 8 of them will have a built-in redundancy, and the camera is already connected to the ROV through, for example, a MUX. So that data link up to the vessel is actually quite robust, so that will also save you the risk of failing sensors. It's your iterative program. You get a real-time data stream. You can project it in any way you would like to visualize it on the top side. You can share your screen with anyone that is actually involved in the installation job. Install the crane operator, someone on the deck. They can have a real-time insight into what's exactly happening down at the seafloor. Not having to install or remove sensors, making lifting operations redundant, is actually a very large cost saving. They can run up into sometimes days, but not having to install sensors, for example, in risky environments, can also increase your weather window. And that's a case study we'll come on a bit later. So accelerating your schedule will save you cost in your project bottom line. And not only will it save cost bottom line, but of course it will give a very positive impact. So saving vessel time, burning less fuel, having less people involved in the installation job on the vessel, and maybe saving on mobilization costs will bring down the CO2 footprint of your project. So to bring it to more of a practical application, I have a case study. So this was with our client Shell. And we were asked to assist in 8 guided conductor installations. This was in the North Sea, so we had quite a challenging weather window. And it was not a very typical job for our client. We were dealing with strict tolerances. And yeah, as you can see, a moon pool where people had to actually go into to install the gyro pack. The initial approach was this gyro pack to be installed. The bracket alone is already 200 kilograms. So then you put a larger gyro pack on. Obviously, you need a crane to do that. And there were at least 3 people involved in the moon pool to run this operation and install this gyro pack. No matter the weather, there was always a rescue vessel on standby, just in case. So obviously, this constricted the operation quite a bit when weather turned for the worse. And actually, that is exactly what happened. So at some point, we had a really bad weather window. The gyro box couldn't be installed into the moon pool. People were not allowed to be there. And we already proven with 3 other conductors that we could do this exactly as required and within the tolerances using quick vision. So it was either choosing downtime or choosing quick vision as the primary solution for this positioning job. And we chose for quick vision. The client trusted quick vision to do this job. You see one video on the screen. So this is what it looks like. You can see the pattern on the left video, if it's playing or it's not playing. And on the right, you can see a zoomed in view on the actual bottom of the conductor. You will see that the penetration is measured in real time. And at the moment that the elevation line of 5 meters is penetrating soil, you will see that that reading will be exactly the same. And that reading is completely based on quick vision, no other sensors attached to that conductor. So what did this mean for our client? In the end, we saved 10 days. 10 days of expensive semi-submersible drilling rig time. So that's quite a substantial saving. We all know the cost for drilling rigs in the North Sea. So choosing Quick Vision as the primary solution was a real benefit to Shell at that moment. They were really happy with the job, and yeah, we've been using Quick Vision with them in the North Sea more often after that. Another use case is for installing pin piles in this case. So this was a client in Qatar. The client had already contracted Fugro to position this frame for their piling operations. And they contracted us with a typical scope. Please position our frame at 7 different locations. And the position of this frame is quite critical because it's used for mooring a floating platform. The solution that Fugro proposed before knowing about this camera in the region was to use USBL beacons. However, the client had a concern around using USBL in these waters. It occurred quite often that the signal was lost, and that occurred in downtime. So actually, they were quite open to our suggestion to try something new and to use Quick Vision patterns instead. So we commenced the job. We did the analysis together with the client on how this would impact their job. And we estimated that the impact on their work would be saving about half a day of drilling of installation rig time. This is the actual footage of the job. So you can see on the left our surveyor packets on Starfix. That's where Quick Vision runs in as well. And on the right, it's the actual footage of the cameras I showed at the start of this presentation. Very crisp image. Actually, we got a feedback of the ROV surveyors. They liked our surveying camera quality better than the camera that was on their ROV at that moment in time, because it has a very wide field of view. But you can see the structure updating in real time on the map, and it was a huge help to the crane operator to install the frame on the exact right location. So debriefing with the client, we did the analysis. We thought we were going to save them half a day. Actually, it turned out that we saved them 1 day of installation work time. Furthermore, the client appreciated the real-time data. They had one other sensor installed on that structure, and they wanted to cross-reference between Quick Vision and that sensor. And it was a huge help for them to just make decisions on the spot and to actually understand that the frame was on the exact location where they needed it to be. I was talking about the Augmented Toolkit, and that sometimes the use of it just pops up randomly. In this case, one of the piles was installed, but we wanted to understand what was the inclination. And this was now as simple as just pulling up the inclinometer tool, flying around it, taking the measurements, and no need at all to interface with the actual ROV to that pile. So we had a result back in, I believe it was less than 25 minutes. So the client on board felt comfortable continuing with the job. I hope that these examples and the technology made you think about potential applications. I can understand there may be some questions as well. So I would like to wrap up this presentation and have your questions. Thanks.
We have a question? We have a question. Can you hear me?
Yes, hello, Kenneth Solbjørn from Åkrehamn. Thank you for a nice presentation. Interesting. I was just wondering, how do you position your ROV in this environment? Do you need position reference for the ROV? Are you relying on SPL or relying on simply on INS? So, yeah, could you just elaborate a bit on that?
So it's depending on what the exact scope of the job is, of course. If we are positioning a structure subsea, we are relying on USBL positioning of the ROV. We can enhance USBL accuracy by using the INS, for example. So that's a different solution. That's just complementing this packet. So we treat Quick Vision just like any other sensor, but then having nothing attached to the structure and only on the ROV. So it's mostly focused on removing sensors from that asset. You don't need any positioning if you do the relative positioning. So whenever you're landing a blowout preventer on an existing well, that type of positioning doesn't need anything of the ROV besides a gyro or an INS to actually get to that accurate pitch roll and heading reading of your asset.
Thank you.
Any other questions at all? How many people do you require for this then? I mean, this is Who grows gear? This is the, do you have to send the guys offshore? Do you provide the people?
Yeah, so it depends if we are operating the ROV or tagging on someone else's ROV. But it's a simple one surveyor job. If you want to have around the clock operations, that may increase to 2, maybe 3, depending on what the client requirements are. But in theory, it's just one surveyor that is able to operate this software package. Yeah.
Okay, another question?
Yes, Elizabeth from Subsea 7. Looked like you've got some really good track record there. What water depths were these completed in? Could you?
Yeah, definitely. Yeah, thanks for the question. The water depth of the guided conductor, honestly, I don't know. This was about 4 years ago. It was waters, Brazilian waters.
It said 760 meters.
760 meters. Okay, so 760 meters according to Quick Fishing. No, so that was deeper waters. The Qatar job, it was shallower waters, about 60 meters. And we have been using Quick Fishing now as deep as 1,800 meters in recent work in Brazil again for torpedo buy installations. So you may have seen that news release. But we have been using Quick Fishing successfully for torpedo bow release and positioning in very deep waters.
Have you seen any interference with, like, when there's matter in the water, particles, fish? Is there any interference there?
Yeah, so of course it's a vision application, so you need to see the pattern. It actually comes back to the pattern design. So we only need 8 of these black dots to have a solid track. There may be up to 32 dots on each of these patterns. So it can either be damaged, you don't need to have all the dots visible. In very murky waters, I mean, at some point you'll start to come into a range where too murky waters are limiting the view. If you have to get closer than 1 meter to the structure, that may bring other concerns. And yeah, you may want to refer back to typical positioning methods. That's more of the ruler wasn't replaced by a total station kind of case.
Okay, and the last question, sorry, because it's quite interesting. Obviously you just don't stick it on the structure. Is there some type of dimensional control that needs to be, what are you doing there then? Is that still total station or?
The exact procedure for dimensionally.
General.
Yeah, no, so indeed it is important to know the relation between the pattern and the CRP of the structure or whatever reference point the surveyor chose. Because that relation will actually position the structure. Otherwise you will be positioning a pattern, which sometimes may be interesting. But in the case of asset placement, you need to understand the relation between pattern and structure. And that's the dimensional control server.
Okay, thank you very much. I think the schedule is, there isn't one anymore, is there really? What would you like? We're 15 minutes to the next one, but we haven't really had a break, which is what we have. Next one, we'll just continue so much of somebody. Go ahead. Thank you very much for the very interesting. Thank you. Okay, so we've got 2 more presentations today. Already 3 very good ones. I'll say so myself. We're going to have Sandrina from RTS now, and then we'll have Rasmus and afterwards there will be some words from our lead inspectors.
Is going to
So, excuse me. We will then continue with the presentations. I don't know if you are interested there on the back. But the break was supposed to be now. We've done it before, so we'll just continue it. Carry on now with the presentation from Mark. Thank you.
Good afternoon. I'm Conductor from RTS in France, which is a specialist in underwater acoustics and AUVs. And today I will introduce about our AUV Comet 300 and seabed battery and mitigation capabilities. So, a few words about RTS. It has been established in 2010. We are a team of 40 people, half of which is engineers and PhD. We are exporting over 70 countries, and we have 4 sectors of activity, half in defense and material, half in civil science and industry. So we started in 2010 with some research and development with the design of the ASDA voting motherboard that has 4 acoustic channels that are synchronous. In 2012 we started with launching the different products with recorders for passive acoustic monitoring with and AUV range. And since 2015, so we are extending the activity abroad with the distributors. We are established in Lorient, it's in Italy, north France, and we also have some offices in Singapore since 2018. So here's show our worldwide footprint. And as I said, 20 people of artists are involved in the research and development department with different expertise, mechanics, and robotics, and electronics, software, and the acoustics. And as I said, we have 4 different sectors of activity, half defense, and we also have farm and AV. So this is what we have today. Here are a few references of clients in the defense, also the defense International Research Institute, clients in the different industries, in offshore and also renewable energy. So there's a lot of Comet 300 and the different uses and applications. So it's an autonomous vehicle. It can operate in 300 meters per day, and it has an of about 20 hours. Of course, it is dependent on the different payloads that it is having. So generally, we are talking about 12 hours with a speed of 4 knots. So the length of the AUV is starting from 1.5 meter, and can go until 2.2 meter with the different payloads that we have. So we have different payloads, sites, and sonar for signal mapping, bathymetry, magnetometer also to detect the magnetic objects, CTD probe to make some environmental studies, altimeter, and also monitor sensors. As to the navigation capabilities of you have the common sensors, GPS, IS, and DVL, and you also have our own protocol that is a spots positioning and communication sensor that enables us to have a very accurate positioning of our ADP at the bottom. So I will play a short video just to show the programming of the mission. So before launching our ADP, which is autonomous, we program a mission, the mission on our Custo software, which has which we have downloaded maps, real maps. So we just add all the vehicles that are going to be part of the mission. So the ADP, and so we program all the different ones as severity, attitude, diagnostic communication, or the different payloads as well that are going to be part of the mission. And once it is done, we can start with creating the first navigation well. So we can be sure the well the path that the DAV is going to follow, and then we can create a family well. And of course, we also create a start waypoint and end waypoint. As we have active communication, we can update all about battery level and different sensors. So once it is done, we can roll all the mission on the API. That is then going to do the mission. Here we can follow in real time the rails where the API is in the water. And at the end, when the API is coming to the surface, we use geosys localization remote. That has to GPS where the API is on the surface, and then it's easy to retrieve it thanks to school and to it on board. Once we have it on board, then we can download the data thanks to internet and start to data processing. So here we have an example of battery data processing. Get an image of the seabed in 3D. So we also download here this example all the images from the side scan sonar. So we have a mosaic of different images, and then we clean each image in order to get a nice seabed image on which we will be able to identify the point of interest, and then to measure the target. So here it's mine to measure the target, to geolocalize it, and also to zoom in it. So it can be interesting, for example, to do a first pass with seabed thanks to the ADP to identify the points of interest, and then to have, for example, our orbit going back on the second mission to treat that would directly to the points of interest. So as we saw, it can operate in 300 depth. It is ended very easy to use. Two persons can deploy the AV from a rig or a vessel as well for a motion map. We were able to know in real time where the AV is located in the water and for spots and the capabilities and more communication. It has also the possibility to work in small group, meaning that several ADVs can work together. We have a master ADV controlling the other ADVs, and they are all communicating together. Speaking about applications, so as you saw, we can do some seabed mapping. We can also do some UXO survey, inspection surveys, offshore wind farm, and also water quality against the different probes. So we made a focus on the seabed imagery to show some images from the side scan sonar. So here on the example, we can see a line with a length of 2.8 meters and a width of 0.7 meters, and it was from a 10-meter altitude. Some other examples here, we have a wreck, so it was also integrated. So here the nest is over 100 meters and with 11 meters. And here also another number of operators have been identified. Here it's also a small video showing the side scan sonar. So here it's we have a water frequency side scan sonar. Here it's with 900 kHz. And you can see on the top left hand that there is a cable, like an 8, and it's about 4 centimeters, 4 meters width. So applications on this as well. You see seabed, and it's possible to see mapping in very quick time and on the right area, but you should as well to get 3D images. And so it can be useful in network inspection with survey and also the list surveys, and also to inspect some cables or impacts. Focusing on the magnetometry survey, so we have also different surveys to see the capability of our side scan sonar plus magnetometer. So it was not the exact experiment, but just to show you that we have a total magnetometer that is 5 meters behind the AV in order not to be disturbed by the magnetic noise of our AV. Picture. So we know that our AV proteins 2 to 3 nanometers magnetic noise. So that was the first part with the side scan sonar, on which we could identify 2 cables. So the first one is 10 centimeter, has a density of 10 centimeter, and the second one 8.6 centimeter. And you can see also the junction works, and we use afterwards for Manageability Toolkit. On this area, we could identify 2 points of interest. So here, a loading chain and loading blocks. Also, we can see on the curve that there is once the detects some ferrous objects, and there is a deviation, what we call the magnetic anomaly, and the importance of deviation is also dependent on the importance of the ferrous signature of the products. So let's show, for example, when doing data processing and how it works for the magnetic anomaly. And I received on Tuesday of the last image from a site that was done last Monday in western of Italy as well, on floating wind farm, and they could identify this chain that is about 20 to 30 centimeter in diameter and 20 meter long. The applications as well, as well the size and sonar, so it's interesting to, for example, for the wind farm section, to some degree surveys, laser surveys as well, and of course, cables and impact surveys. So the combination of both side scan sonar and Magnetometer is very interesting. It also see anomalies on the different survey lines, and to correlate it with the information from the ZIFRO and to the side sonar, and then we can estimate parameters, shapes, and the early days, and also to geolocalize all the different points of interest. Thank you.
The first for some questions? Are there any? Hands up.
Hi, Johnson, on engineering. On one of your first slides, you mentioned a 5,000 meter music communications capability. Can you share with us what sort of bandwidth? Do you have that range?
Yeah, actually, that's a very good question. Good question. It's, well, I would actually have to come back to you about this one. It's something new that they put on our catalog, and I will try to get information from something that I saw as well. Yeah, I cannot give you right now the information. Sorry.
Okay, do that. Anybody else? Okay, Thank you very much. So we have one more presentation. Do you want to say quick break? Because I think it's hard to say. I'm really looking forward to the most represents the results from last year's the alcohol fueled system. It's exercise we did in Survival. So I think we'll have 5 to 10 minutes. Okay, 5 to 10 minutes. Thank you. Thank you. All right, you guys try this? People? Okay, the history here, I think those who were not, and you just have to not at the annual dinner that we had, I think it's about last year. It's really organised with the help of Victoria Divine last year, who's now works in the academic world. This is students. I go along to different systems dynamic eating exercise. I always really good by doing some different presentations. We won't do it again this year, but we do something different. So I would recommend that you do, if you haven't considered it, make sure you put it in the annual dinner that will be on 17th of November. So we're going to put that. But here, after almost a year, it will be an element of the results from that meeting presented by Rosner staff from and more working so Rosner, thank you very much.
Can everyone hear me okay? Just gotta test the sound a bit. He already said my name and he's already hyped me up, so I'm nervous. My name is Rasmus and I'm studying for a PhD at the NHH. And yeah, I work mainly with mathematical modeling to study issues relating to natural resources and natural resources management. So currently I'm working on several projects. I'm working on a project relating to fisheries and a project relating to bioenergy. But I'm also working on this project relating to deep sea mining, which I'm going to talk about here today. So the main message that I want to get across today is that deep sea mining could represent a great opportunity for the offshore industry. And I guess many of you already know that, so I'm going to focus a bit on how it could represent a good opportunity for the offshore industry. So, yeah, as Stuart said, there was a workshop last year led by Lars Christian Kalevik, my co-author, and this project ended up being part of, or this workshop ended up being part of a bigger project. And I'm not sure how good that is, considering Stuart told me that everyone got a tiny bit intoxicated, which is perhaps a bad starting point for a research project. Yeah, maybe people loosen up a bit. That's good. Yeah, so in this bigger project, we attempt to map the processes of exploration and extraction of deep sea minerals at the Norwegian continental shelf. And in addition, we try to evaluate the expected resource and economic potential of this industry. Now, this is an emerging industry, and there is a lack of data. So what we've done is that we have tried to gather as much information as we can, partly by visiting the literature that is available. But since the numerical and written data is scarce, we had this workshop, and then we've also had a range of interviews with different experts from the industry, but also from the academic atmosphere and also from public policy, from government. And then gathering all that information and then putting it into a model and see what comes out. So, yeah, the plan for the presentation then is to give you a high-level overview of this model that we built. I'm not going to go into detail, but I want to explain what it contains, and then if you're interested, you can ask me about access to the model later. Yeah, and then I'm going to talk about our results and what they could mean for the offshore surveys. So, first some background and motivation for this project. Obviously, seabed minerals have already been identified on the Norwegian continental shelf, mainly in the forms of seafloor massive sulfides, which contain copper, zinc, cobalt, and different metals that are important in the society that we live in today, but especially also for the green shift. And then we have manganese rocks, which contain manganese and also rarer minerals and other minerals which are also important. The North project, we focus only on these sulfides, so copper, zinc, cobalt. And in 2019, the Norwegian Parliament passed the Marine Minerals Act that is intended to facilitate exploration and extraction of marine mining. And in 2023, they are scheduled to vote on the formal opening of the Norwegian exclusive economic zone for these activities. And already there are several exploration and production companies that have been established, and I guess perhaps some of you are also positioning yourself for this opening process. And while all this is happening, we're also seeing the demand increasing, partly due to population growth, economic growth, the green shift, but also due to geopolitical polarization. Because today, Europe depends a lot on imports from China, Russia, when it comes to metals, and the recent development makes the European Union and also the West in general take more security considerations regarding access to critical materials, including minerals. And at the same time, you have the onshore mining industry facing challenges of its own. We're facing declining resources, falling ore grades, and increasing extraction costs. And all this is, of course, well and good for the prospects of marine mining on the Norwegian continental shelf, but there is still a lot of uncertainty revolving around both the resource potential and the economic potential of marine mining at the Norwegian continental shelf. So that's why Lars Christian and I, we decided to take it upon ourselves to try to gather all the information, as I said, and see what we know for now, and then use that to explore the possibilities and perhaps what's important to think about. So on the next slide, I'm going to present you a high-level overview of the model. I'm a bit worried you won't see everything, but that's not the main point. I just want to give you an idea of what the model contains. And it's very simple compared to the one we've actually made, so I've done my best to make it as small as possible. Okay, so the main idea is that we have 5 sectors. We have one sector describing the exploration process, one sector describing the exploration technology, one describing the mining process, the mining technology, and then a sector that takes care of the financial accounting. And the exploration process is first in line, so I'm just going to talk a little bit about how we define that in the model. And that's we start out with this big area that we think there could be minerals somewhere. And then we conduct regional surveys with surface vessels. And then after that, and after evaluating the data from those surveys, we conduct a high-resolution survey. For example, these AUVs that some of you have been talking about. And then after that, and evaluating the data from that, there is coring. Taking coring samples to figure out what was the mineral concentration in this area, and would it be worth trying to extract those resources. And yeah, that's the main thing to take away from here. And then I'll just move on straight to the results. And what we investigate are 3 scenarios. We have one scenario where we consider average ore grade of 3%, mix of other zinc and cobalt in the ore. And then we have one where we consider 4% and one where we consider 5%. What's a bit interesting regarding these scenarios is that when we talk to industry players working with this, they're saying 5%. It's going to be, that's what they expect in terms of ore grade. Of course, no one knows this for sure. There's been a few samples being taken, and there is still a lot to be explored, but the industry is generally expecting 5% concentration. But when we talk to the academics working with the geology of all this, they're saying, oh, that's a bit too ambitious considering all the other assumptions that were made in this model. So they're saying 3%. So we take kind of the academic perspective, industry perspective, and then the middle in between them. And then we simulate the model over 50 years. And then there is this fancy word Monte Carlo simulations. Basically, we're just running the same simulation over and over again with different paths of uncertainty. So there is sort of this randomness in this model as well. So first, the costs associated with exploration. These are the costs that we go through with everything. We explore the entire area. We take the resources we find and we extract them. And then you see that we're talking about quite a bit of money here. The expected costs associated with this exploration. It's a capital expenditure of $3.5 billion and also approximately $7 billion in operational expenditure. So it's going to be costly. And then we look at the mining capex and OpEx. And as you can see, those are also significant. And what we get in terms of resource estimates is between 1.8 and 3 million tons of copper, zinc, and cobalt, in which copper makes up the most significant part. And that's quite a bit. And as you can see, that generates quite a bit of revenue. And the net value, that is, if you just take the revenue minus the cost without discounting anything, then you're ending up with quite a huge surplus. But when you look at the net present value, which is the discounted net present value, you see that that's negative for the 3% case. That's the academic expectations, as we call them. And then it's positive, you see, for the high-grade scenario. And the reason for this is because we have all these costs in the beginning, long before you're generating any revenue. So your costs are high while your revenue is discounted quite hard because they occur far into the future. So what's the takeaway from this when it comes to the offshore survey industry? We find that one of the main challenges regarding deep sea mining is the high initial exploration costs. And these are especially tied to coring. Because we need with today's technology, based on what we've heard from the industry and what we've talked to, is that it will require a lot of coring to identify these resources. And coring is expensive. So what can the offshore survey industry do? Well, perhaps they can try to reduce the cost associated with coring, for example, by reducing the amount of coring with better AUV technology, for example. Because with better AUV technology, perhaps you will be more able to identify sites that are actually interesting to do coring. So, yeah, that's basically the take-home message, is that it's not given that this will be profitable industry level. And what the offshore industry or tech industry can do is to try to help reduce that risk of going with a loss by innovating and finding new technology that helps save costs early on in this process. But yeah, that's it.
Yeah, okay, that was a very rough finish. That's a rough finish code, that's it. That's very interesting, I found that interesting. You basically saying that if we up our the people in this room, then push this, then everything basically improves along. That what you're saying?
Exactly, for the industry as a whole.
Right, no pressure. Okay, wonderful, thank you very much. Does anyone have any questions, please? Michael?
I'll just shout. I'm just curious, on the previous slide, you had the exploration capex.
Yeah.
I totally understand, almost $7 million exploration capex. What cost really not $1 million to exploration capex, considering the technology already exists?
We've included,
Most of the tech already exists.
yeah, we've included building the ships and also maintaining the ships. That's part of the capital expenditure.
Okay. I think you're talking about new vessels rather than just.
Basically, and production of technology that is meant for these steps that we're talking about.
Okay.
Yeah.
I was going to say, I'll take 3.5 minutes.
Yeah, but that's what I'm saying. There could be a lot of money involved here, especially for you guys in survey. And but then, of course, someone needs to make that investment, and to make that investment, you don't want to see those red numbers over there, because then you will be more hesitant to invest. But if you guys can help them reduce these costs by inventing some magic AUV sensors or something, then and reduce the amount of coring without reducing the quality of the exploration process, then maybe that could be a cool thing. But just a disclaimer as well, that we're basing this on the available literature, which is scarce. So we also rely a lot upon information from stakeholders in the industry and academia and the public policy sector. And a lot of these things that go into the models, we don't have data for. So they are guesstimates. So this study as a whole is kind of speculative in nature. And that's important to keep in mind. So yeah, just want to say that as well.
Do you have any locations or classifications on what the left side of age or any areas already identified?
There is something going on regarding deep sea mining.
Yes.
It's deep water. We're talking 2,000 to 3,000 meters. There is a huge discussion revolving around. Okay.
So this is based on the Norway potential shots. I presume you could do this on your look for other regions. You could extrapolate this out if you wanted to.
Yeah, then you would initialize this model with different values. Like for example, we initialized the model with 80,000 square kilometers of area that we want to cover, and then all these percentages and different things that enter the model, they are based on knowledge of the Norwegian continental shelf. So that would obviously change, but the structure could be largely the same.
I'm very curious how you different things into a model. Okay. Is there any other questions before we wind up the presentations from today? I think it was very interesting. I've seen really the alcohol fuel disability thing that we had. So they not contribute that much. So we can always try again.
Yeah, but if it's wrong, then I'll blame you guys.
Okay, on that,
thank you very much for office.
Yeah, maybe we'll round off. Yes, all the presenters. Everyone can say please.
A little thank you.
Okay, come forward to the end of the stage, please. Michael, thank you very much.
Absolutely.
Thank you.
No environment, thank
Oh, I'm on stage as well. I'm great. No. Come down then.
It might still be alive,
Okay, I think I'm going to present this.
Okay, that's it for us. You can't believe how much effort actually does go into putting together all the presentations. So like I said at the start, if you've got anything to say, please come forward because it makes our jobs a lot easier. And I do think these evenings and days that we have down in Stavanger, in Bergen, maybe even over in Oslo next time, they are very worthwhile. And I get them like that anyway, and I think most people do as well. So if you're going to appeal course as well to a younger audience, that would be a move too. So I think on that note, I will say thank you very much from me and the team at NOSP as well, because I couldn't do it without them. So if there's anyone wanting to join, give us a shout. So thank you very much. I'm going to hand you back to Dawn
Okay, everyone. That's the formal part of the program. Then done. Lots of good presentations. Now we are moving into a little bit more informal. Now it's all about talking ideas, talking challenges, seeing if we can get some synergies among the crowd inside the house. We have our partners presenting different type of equipment. So there are different tests. So Nortec brought some equipment, Asher has equipment. So we got some